I'm Scott, and this video is a follow-on from my previous video which showed how I came up with this design. It's a contactless flux generator for my bicycle. So this video is going to show how to make some lights to work from this generator. And we don't just want lights which flash like this one. We also want lights that are strong enough to actually light up the road in front of us. Let's say you're riding on a trail, there are no street lights, and you need to see where you're going. So we need a beam which is strong enough to do that. So let's go see what kind of a circuit I can come up with for this generator. What are you doing? What? I'll use a breadboard to lay out this circuit. 2 wires for the alternating current. Just take the current in and take the current out. Connect it to 2 cob lights, which are also acting as diodes and rectifying the current under 1 channel. So regardless of which way the alternating current is flowing, it's still going to go to the positive side of the capacitor. The capacitor will then feed the 2 LEDs, and that will provide a constant light. We now need to take the current back to both sides of the alternating current, and we need diodes for that to prevent the current going in the wrong direction. And that is the circuit. Current goes in through the cob LEDs, capacitor, the LEDs, and back through the diodes. Let's give this a try in its current state. And first, the cob LEDs flash, the capacitor takes up the charge, and the LEDs then light up as the capacitor discharges. So we have the flashing lights, the cob LEDs, and then just the regular LEDs, which are constant. And the circuit seems to work. And as it slows down, we should see the cob lights go out and the LEDs stay on for a short amount of time. Under the soldering, and I must admit that I am probably the world's worst solderer, but anyway, here we go. The 2 cob LEDs are soldered together. The incoming current, alternating current, passes through the LEDs and is rectified into direct current. And the smaller LEDs need to be connected to the capacitor. The negative side is connected to the negative side of the capacitor. And the positive side of the LEDs has to be connected to the positive side of the capacitor. Like that. And then the cob LEDs and the regular size LEDs need to be connected. So the rectified current has to go into the capacitor, and that's what I'm connecting here. Soldering so the incoming current can pass directly into the capacitor. and then into the other LEDs. And finally, we have the two diodes, which have to take the returning current. That current has to find its way back to either side of the alternating current as it fluctuates from one side to the other. So the negative side of that LED is connected to the diodes, and that current can then find its way back to whichever side of the alternating current that it needs to go. Just bend them round and down. And solder it all together. And those diodes have to be there to prevent the current from going in the opposite direction. The circuit will not work without them. And there you have it, the finished circuit with the two cob lights and the two smaller LEDs. I've connected this very loosely to the generator just to give it a try, just to make sure the circuit is working correctly. It's nice and bright. Two cob LEDs are flashing, and the smaller LEDs are taking the charge from the capacitor, and they stay on a little longer. I need a case to keep the weather off the circuit. So this is what I came up with, just a very simple design, purely to hold the lights and keep the weather off them. It sits on the bracket that I've already made, it's already fitted to the bicycle. The main compartment holds the circuit and the lights, and the cap at the end fits in snugly and also holds up the capacitor. The capacitor rests on it, and there are two holes in the back for the wires coming out. This was designed on Wings 3D, which is open source and really easy to work with. Okay, let's print this. Let's get my 3D printer working. Let's print a rim for adhesion first. This is going to print quite high, just to ensure that it doesn't break off the build plate. It's an old 3D printer, but I should probably get a new one, but you know what, it works. And there you have it, the finished print. Let's take the rim off, and there are the two parts. Let's feed the wires through the two holes for the alternating current coming in. And if I've printed this correctly and my measurements are correct, this should fit perfectly. Oh yeah, yep. And then just insert the cap at the end, which is also going to support the capacitor. And yep, that's a snug fit. That is ready for the bike. I connected this up very loosely just to see how this works. And there you go, we've got the flashing cob LEDs and the constant smaller LEDs working off the capacitor. And let's see what kind of light this shines in front. Let's get it up to speed. And then I'll turn the light off. There we go, the camera is going to adjust to the darkness, and yep, that is bright enough to see where I'm going in the dark. The lights work, they're visible, the cob LEDs flash, and the light is dispersed at a wide angle. It's really good for being seen at night. The two LEDs are bright enough, as you saw, to light in front of the bike to see where you're going. Yeah, it worked. I could refine it a little bit, add some reflective aluminum foil behind the LEDs to reflect the light. But it's functional right now. One thing is niggling away in the back of my mind, and that is, what if I'd used bigger magnets? What if I'd used more coil? How much current, how much voltage would that produce? Which has led me back to a design, a configuration with the magnets that I have used before to increase the strength of the magnets. There are 3 magnets here, 2 facing the same direction, 2 of those magnets, and they have to be actually forced into position. They do not want to be facing this way, facing together. They have to be held in position, and what that does is it makes the flux from the 3rd magnet much stronger, much stronger. So with that, with the 3 magnets, a larger area now for coil, for more coil, should be able to produce more voltage, more current, and hopefully I can get some more lights working from this design to make it brighter, but that is for the next video.